Okay, hey, I'm Julian. I'm on GitHub and Twitter as Julian Gruber, and I'm a software engineer for NSQ, and we're doing mobile app security and forensics. I'm not working in forensics, I'm not that smart. I work on the infrastructure and front-end stuff, but a lot of the infrastructure. And message queues are something we rely heavily on. And I'm going to talk about a particular one. But first, who has used a message queue? Okay. And who has seen a talk about RabbitMQ or any other message queue? Okay. So some concepts should be familiar, and especially how a message queue works. But the one I'm talking about, which is NSQ, is somewhat simpler than most. Okay, so first, what is a message queue? A message queue helps with one-to-end process communication, like an IPC tool, although you can also use it in one process. And it helps making your code work asynchronous, like if someone produces a thing, it doesn't have to be consumed immediately. It helps with resilience, because messages will be requeued if there's an error processing them, and it works with scaling. And some popular message queues are RabbitMQ. You can also use Redis as a very simple message queue, and Kafka, which is more complicated. But I'm going to talk about NSQ. Who has heard of NSQ? Okay, one guy. Very good. Okay, NSQ is a message queue written in Go. And why did we know? No,
The logo is nice.
Which one? Yeah. Yeah. So the website is NSQ.io if you want to read on and stuff. As they say, it's a real-time distributed messaging platform designed to operate at scale, handling billions of messages a day, and more stuff that we only know. So the cool thing is that NSQ is very simple. So I'll start by installing NSQ. You just grab the latest release for your architecture. There's no Windows build because Windows is kind of irrelevant for message queues, as it seems. So I already downloaded. Sorry, well, not sorry. So I already downloaded NSQ. And what did I? Yeah. So it's just a bunch of bins. The way to install it is to copy them to something that's in your path. Oh, if I make a mistake and you spot it, please tell me. Okay, so now we have NSQ installed. And you see there's a bunch of binaries coming with NSQ, except the first one, that's a private one. But the main thing we're going to use is NSQD, which is the actual queue. Okay. Next, well, let's make a temporary folder and start NSQD, and it's running. Then let's connect to it using Node, obviously. Is this? I think this is big enough, right?
Yeah.
Okay. The binding we're going to use is called NSQ.js, written by TJ Holloway-Chuck of Second.io. And so with a message queue, you always need two parts, a producer and a consumer. The producer pushes messages into the queue, the consumer takes them off the queue. First is create a dummy producer, or say publisher or writer. And we pass it the address. And let's publish something. Okay, the next thing to know about NSQ is that its data model consists basically of topics and channels. This is the topic. The topic says what kind of data you have. So a topic would be event, or a topic would be artifact, or it would be real-time thing, or it would be orange if you're sending oranges. So that's the topic is what your data is. So we tell the writer to publish to the event topic, the event foo. Let's see if that works. Yeah, it's still connected, that's why the process isn't finishing. So next we need a reader. Reader needs more options. First needs to know about the NSQ address. Then you need to give it a topic, which would be event, because here we publish to event topic. And then it needs the channel. And the channel is something the reader defines because you can imagine you have multiple topics and each topic runs into n channels. So you don't consume off the topic, you consume off the channel you created, and this will make sense in a second, I promise. So let's just call this dummy. And when the reader gets a message, we have the message.body, for example, which is a buffer, forward it to a string and block it. Let's just do this for now. And it's not doing anything, probably because I passed the wrong port. A personal thing, it's so great to have working Wi-Fi giving a talk. That's awesome. Okay. Yeah. So each NSQD has an HTTP and a TCP port, and I always forget which one to use. Okay, so we got this event, which is super exciting. Yeah. Okay, let's publish more. Let's create like an infinite loop. 10 messages a second. And watch it go. So it stopped after 10 messages, which I planned for, because with NSQ, when you take a message off the queue, of course you need to tell it, okay, I'm done with this, or no, requeue it, there was an error. So we need to finish the message. If we do that, you'll see, okay, there's a bunch of messages coming in. I'll make them more random so you can see it. This is just creating a random string. Okay. Yeah, you see there's the foo, there's one of the foo messages that got requeued because we didn't acknowledge them. Okay, that's still basic stuff, but it works. And I think the API is quite simple to work with. Now, a very helpful tool that comes with NSQ is NSQ admin, which we just need to tell about the NSQ address. Which is, I think, this one. 4171. Not this one, but this other one. Yeah. So this is a web frontend that comes with NSQ that usually you tell your ops guy to just run somewhere on your infrastructure. So we can inspect the topics. We just have the event topic, and we see there's one channel called dummy. And you see how many events NSQ currently has buffered, both in memory and in disk, on disk, how many time out, how many there are in total, blah, blah. Okay, this is pretty basic. But let's say you want to do different things with messages. So if you have like this one stream of events, like for example, you're a surveillance company and you take all the events that a phone emits, like who is calling, this and that, and you want to do multiple things with that. You want to persist those events on disk for later reference, but you also want to analyze them. So you have this one topic, events, but now you need two channels because each channel will serve a different purpose and each channel will get each event. Let's see, or also let's move to multiple processes to make this a lot more interesting. Let's have a producer. A consumer. And one more screen. Let's try this out. Okay, so working. Now we say we need different consumers, right? One, for example, for buffering events and one for analyzing events. So we added the consumer thing. We will just use standard arc to pass the channel. Now we made the channel dynamic. This is where I should learn the shortcut for splitting horizontally. Okay, so let's create two consumers. One consumer, one channel. Let's call it buffer. Actually, let's pause the producer. And one consumer on channel analyze. Okay, and let's start the producer. Now what you see is each is receiving exactly the same messages, but if we use, for example, the buffer topic for both, you see that now messages are load balanced between those nodes. So by just using topics and channels, you can create a bunch of different topologies in your data. So you can route flexibly, but also scale without changing the producer. The producer still is the same. We just added new consumers. We didn't need to configure any new, I don't know, channels or something other queue systems. So for example, in a real-world scenario, you would run like 5 consumers running the buffer channel and 10 consumers running the analyze channel, because that's more, it takes more CPU or something. And if you want to scale your system further, you just put more consumers. Okay. Let me peek at my outline. Okay. Wow, I'm quick. Shit. Oh, sorry, this is the tape. That was a verbal typo. Okay. So, any questions so far about this example? Like all this stuff?
Very nice.
Okay, cool. So the next thing is how do we deploy NSQ? Because that's like learning about NSQ's deployment not only teaches you how to deploy NSQ, but also shows another very interesting feature of NSQ and how it helps create a scalable system that is highly decoupled. So as I showed earlier, there's multiple binaries coming with NSQ. So we have the NSQD, which is the actual queue, but we also have NSQ lookup D. And NSQ lookup D is like a router node. So in a real world scenario, you don't connect to NSQD directly. You connect to NSQ lookup D and ask it which NSQD should I connect to. And I have a graphic for that.
When you press Shift, Command, and Enter, it's yeah.
Ah, thanks. Okay. So, NSQ, the way you should deploy your stuff is on every node, say on any machine that is producing messages, you run a local NSQD. So inside your server.js, you just tell it to connect to the local NSQD. That's what you publish to. So we have two producers in this case. They could be producing data for different topics or for the same, doesn't matter. So when a producer boots up, or when the NSQ boots up, you tell it the address of NSQ lookup D, which would be one or more of those nodes. Ideally, you run like 5 nodes, because that will scale for, I don't know, 1,000 machines or something. So you tell it about the NSQ lookup Ds, then the NSQDs tell the lookup D their address and what data they have, and they do this periodically. So each of the NSQ lookup Ds always knows, if you want this data, go to this node. So next, when you create a client, you point it to this NSQ lookup D, and when the client does creates a reader, say NSQ lookup D, like look up o1.local, and you tell it topic and the channel. Internally, NSQ.js is pinging all the lookup Ds and asking, okay, which nodes should I connect to when I'm interested in this data? Then gets the reply, and the clients connect to all those nodes and fetch data. Now, that's very helpful from an ops perspective, because only once when you introduce NSQ to your infrastructure, you set up those 5 NSQ lookup Ds instances on different machines, obviously. You give them all a DNS address, and then you don't need to configure much anymore. Every time you deploy a producer, you pass it the fixed list of NSQ lookup Ds. Every time you create a consumer, you give it the fixed list of lookup Ds. There's no more configuring necessary, except tweaking internal details. But the routing is pretty simple, pretty simply handled this way. I think if I remember correctly, with RabbitMQ, when you added a new instance, you needed to reboot all the clients and tell it the new address space and stuff. So you don't need to do that with NSQ. It will fetch new nodes, or it will forget about old nodes by just pinging NSQ lookup D. Okay. So now we have 20 minutes left for actual live coding. Okay. So working with NSQ, I stumbled upon an architecture that I found very, very useful for creating services that consist of multiple parts, but you can boot your service locally with everything running in one process, but you can deploy it with to n machines, and each running their own part of the service cluster. And let's create those. Let's call it, I don't know, so. Okay, the example we're gonna use is similar to what I talked about before. We have a large stream of events. First, we're gonna normalize them, and the normalizer does some weird funky stuff, and it's asynchronous, so it makes sense to have it as a separate part, as a separate step in your processing queue and not inside the process of something else. And then we have a buffer service which just buffers the normalized events to this. And yeah, the way we're creating those services allows you to deploy it as one process or as multiple. So first let's create the normalize thing. And that's just a normal lib. I'm going to use a class, because that's what you do in the real world usually. Like in the real world, you will pass arguments to this and store it in state and stuff. Oh, I didn't want to say use prototype inheritance. I wanted to say I wouldn't just use a function here. Like usually you have multiple methods on here to keep it organized. Okay, but our normalizer will just have one function, which is called write, gets an event, and a callback. Let's call it callback for simplicity. In here we simulate some asynchronous work, which takes like half a second. But what we are really only doing is read event.secret and call the callback with the event. So that's a simple normalizing lib. And we create a binary for this as well, which you'll soon see why this is helpful. We create a new normalizer. We use NSQ to connect to NSQ. We use NSQ to JS to connect to NSQ. We'll create a reader to read of our main events channel. There will be a producer somewhere else. We're just consuming this. And the channel is called normalize. And let's give it an NSQD. I think it was like this. It's this one. And every time we get a message from the event channel, we're gonna write it to our normalizer. In this case, this message as JSON. Then we get an error and denormalized message. And if we have an error, we requeue the message. So this means after 2 seconds, NSQ will give it to another consumer again. And otherwise, we'll republish it for the buffer service. So we try a writer. So now we're going to publish it on another channel, which is the channel called normalized. And just the normalized event. And we're going to acknowledge the message.
You have a typo there. You want to requeue MSG, not MSQ. If
No, that's
MSG requeue, right?
Oh, yeah. Thanks. To recap, we now have a library of our normalized service in a binary, and we can run the binary to run the normalized service. If we, for example, deploy it to our infrastructure. Okay, let's write the second service, which is the buffer service. I'm going to lowercase this because there's the buffer variable already, obviously. So the buffer service takes messages, normalized events, and stores them on disk. So we have a write stream just on term left. And here also write stuff to the buffer service. We get a normalized message and a callback. So we call this .writeStream.write JSON.stringify normalized. We with a new line and then call the call. Okay, that's the buffer service. Also, let's create a bin for this.
Type on the normalizer.
Oh yeah, thanks. Let's create the bin. Let's just base it on this one. No. Just need a reader, no writer. Now this time the topic obviously is normalized and the channel is buffer. So that's the data we're consuming. We're consuming the normalized thing and we're calling ourselves buffer. And so once we get a message to the buffer service, we write the message and we just get an error. And if there's no error, we're done. Or let's just log something to start it out, so we know stuff is happening. Okay, so we now have the two services that in total make our whole product. And we can run this. But first, there they are. Okay. First, let's. I have a small utility called a small producer that is producing messages. So we run the producer, and we run the normalizer. And we run the buffer service. And it should be doing stuff. No, it isn't yet. Let's just get rid of all the stuff that we don't need. This always seems to happen once every live coding video.
I think it's publishing to the events topic, but you coded everything to the event topic.
Yes, very good. So let's just yeah. Okay, you should have a convention in your company how to call your topics. Let's fire this in up. Oh, and we see it's working. So here we're creating messages, here we're normalizing them, and here we're writing them to disk. And we could say, just create another normalizer. And now they're sharing work. So you see it's easy to scale the system. Okay, but this is only half of what I promised. This is showing the deployed scenario. But usually when you're developing this thing, you don't want to run 10 processes and like have 10 edit instances open and restart 10 things. You kind of want it all to be in one process. So you edit things, you restart it, and the whole thing is restarted. And that is something to do with the setup. Currently, we have two components in our service. I make a third called cluster, and this will have a local.js, which is not using NSQ at all. This will have a NSQ.js, which is using NSQ, so you can verify locally that it's still working with NSQ. Yeah. So let's do the local.js. We have the normalizer without NSQ. Okay, you might be thinking currently, hey, Julian is rewriting a bunch of stuff. This doesn't look very DRI. But the things I'm rewriting right now is just the connection between the services, not the services themselves. So this actually works well. We have our event. If there's an error, we throw it. We have a buffer source. And once we got a normalized event, we write it to the buffer. If there's an error, we throw. Otherwise, we log something.
If there is an error, the plot will stop.
Yeah, but this file is only going to be used for local development. So it might be okay to just throw in errors. Of course, if you want to test how errors are handled, you should implement something to redo. Let's try this local thing. Yeah. Oh, and this interval should not be too fast. Okay. So this might not be something very special, but it shows that if you write your services in a way that they are not coupled to your infrastructure, like those libraries I wrote, they don't connect to NSQ themselves, they just expose simple functions. And you see, if you do that, you can connect them simply without NSQ, but you can also connect them with NSQ. So decoupling from I/O and just exposing simple functions is very helpful for putting stuff together in multiple ways. That's kind of the Scream philosophy, or like Unix pipes thing.
How do you test this code? How do you test this code?
For example, let's use Mocha, because everyone is familiar to it. If we want to test the normalize thing, you test the libraries, not this file. This file is only used for local development.
Okay.
But here it should normalize.
Yeah, I understand what you're doing.
Yeah.
The reason why I asked is because of the nesting.
Sorry, what?
Because of the nesting.
Yeah. Actually, like sometimes testing those things is
Because
hard.
when you look at the code, you cannot actually test it.
Yeah. But again, this is not to be tested. This is just your example.js file that you run for local development. Yeah, but I've written a service for the company I work at, which consists of 10 components, and it's very difficult to test because you have to keep running it for like 1 day because it's uploading to S3 and because of file limits and stuff. Like it needs to be running for at least a day so you can verify it's working, which kind of sucks for development. Okay, so now we have our local thing for development. We start everything in one process. We can quit everything in one process. But let's create the NSQ version as well. So this is the same thing, it just uses NSQ to connect your parts. Well, I guess you can imagine what this is going to look like. I'll just do it. We publish. Do you want me to write this, or can you imagine what this is going to look like? Because this is just going to be this file and this file in one file. Okay. So it still looks like we have a lot of duplicated code in here. But again, you don't need to update this code when your service changes. You only need to update this code when the topology of your services change, and that doesn't happen a lot. Your service changes happen a lot. So when you're working on a product like this, you will most of the times either be working in a particular service, like you should also have an example JS and just run it locally so you to verify it works. And then when you want to do integration tests, you go to your cluster module and, for example, run the local version, or you run the version that's actually using NSQ. And then when you're done, you tell your ops guy, hey, install this and run buffer bin.js and normalize bin.js on how many machines you want. And just tell him to configure all the NSQ stuff. Him or her, sorry. All the NSQ stuff for her. For it. I'm confused. Cool. Cool. Any questions? Yep.
So the reason I would use NSQ for this over Rabbit or something like that is just simplicity, right?
You could say so. Like deploying an Erlang solution that
Okay, let's say Kafka. Let's say Kafka instead, right?
Yeah.
But
for
because
example, at SecondLR we used RabbitMQ and keep crashing, and we didn't have enough insights into the Erlang VM in order to understand what's going on. And with NSQ, it's written in Go, so it's not very unfamiliar if you need to dig into the code. And you also just run the NSQD executable, and it runs super solid, has a very small memory footprint, and yeah.
It's basically brokerless, right?
I think what you call broker is the lookup thing. I'm not too familiar with the term broker.
The messages are flowing from the lookup, right?
Yeah.
You can just cast it.
Yeah. So the lookup only tells you where to connect to, but messages flow directly from the producer NSQ to the client. That's also why lookups don't need to be very strong. They just do some routing.
So what you're missing in comparison to Kafka or something like that is a message replication, right? And delivery guarantees. Like the producer doesn't know whether there's just no consumer asking for anything, or whether you've actually lost some kind of connection to the NSQD lookup thing somewhere.
Yeah, there's definitely more features in Kafka, especially in Kafka. But the question is, do you need them?
Sure.
And especially, is the added complexity worth having those? But yeah, if you need those, definitely use Kafka, of course.
Okay, cool.
Can I have some metadata on the jobs? Like something like a process bar or something like that?
Okay, so the question is, can we have metadata on jobs like the process bar? One thing you could do is you could manually publish process events if you want to do that. You can use the web frontend to see how many messages are in which channel and which topic. But otherwise, I guess progress is very dependent on what your architecture actually looks like.
I have a job, something like convert me a video, and then the consumer can tell me I'm 10% done, 20% done, and I want to show this information in the front end.
Yeah.
So
okay,
I need a channel for every job.
Yeah. You create a channel for every job. Or you have a channel with a general channel with updates, and your web server just consumes all of the updates, but only tells the clients that need to know about those updates. So it's up to you. But that can definitely be done. Yes?
Is the NSQ lookup D stateless? Or if you have 5 of them running in parallel, do they exchange information with each other?
The question was, is the NSQ lookup D stateless? And if you have like 5 of them running, do they exchange information with each other? They don't talk to each other, they don't even know about each other, but every producer tells all of them where it is. So they don't replicate, but they still have all the data.
I was just thinking about some kind of weird split brain scenario
Yeah.
where some NSQs only talk to like maybe half of the NSQ lookup bees, but the other NSQ lookup bees talk to the other half. And I think this can get weird if they don't talk to each other.
This can get weird, exactly. Then probably NSQ is gonna start buffering to disk because there isn't the consumer there, because the consumer can't find the producer, and it's gonna buffer to disk. But luckily, NSQ lookup D keeps polling for updated data. So if you're lucky, the ops guy has resolved the network issue before there's too much buffer on disk. Again, there probably is a way more complicated but more solid solution. NSQ just aims for the simple but good enough, like the 80-20 rule thing. Okay. Cool, thanks.
Thank you.